Okay, let's be real for a second. Are you a stressed GCSE student staring at a confusing web of crossing lines and angles, wondering how on earth you're supposed to find the missing ones without losing those easy points? Do you want a foolproof strategy to secure maximum geometry marks every single time? Well, you are in exactly the right place.
Welcome to this explainer. Today, we're building an absolute powerhouse of a study guide for AQA GCSE Maths, specifically focusing on angles on parallel lines. We're going to uncover some serious insider secrets, examiner tips, and the exact step-by-step strategies you need to stop throwing away easy marks and start scoring perfectly on these geometry proofs. All right, let's jump right in.
Here is our game plan for today. We'll quickly recap the basic angle facts, dive into the 3 parallel rules, expose the secret letter trap, highlight common exam mistakes, and then wrap up with your strategy for maximum marks.
So, kicking things off with Section 1, the basic angle facts. Look, these are your 3 must-know facts, the absolute foundation. And honestly, they pop up on virtually every single GCSE geometry question. First up, angles that form a straight line always sum to 180 degrees. Second, all angles meeting at a single point sum to 360 degrees. And third, when 2 straight lines cross, the vertically opposite angles, the ones directly across from each other, are exactly equal. Applying this is incredibly straightforward. Say we've got angles of 47 degrees and 63 degrees sitting on a straight line, and we need to find this missing angle A. Because we know for a fact that angles on a straight line add to 180, we just take 180, subtract the 47, subtract the 63, and boom, we're left with exactly 70 degrees for angle A. The math is simple, right? But stating that geometric reason is what actually unlocks the puzzle. Moving right along to Section 2, the 3 parallel rules. Before anything else, we gotta nail down the terminology. Ever heard of a transversal? It sounds super technical, but it's literally just a straight line that cuts across 2 parallel lines. Just imagine 2 long, straight train tracks that are never going to meet. Those are your parallel lines. Now picture a straight road cutting right across both of those tracks. That road, that's your transversal. And at every single crossing point, it creates a whole cluster of angles. Now this is where it gets really cool. This is essentially the ultimate cheat code. When you have parallel lines cut by a transversal, you end up with sharp, acute angles and wider, obtuse angles. Here is the massive top tip. For that same intersecting transversal, all the acute angles are exactly the same size, and all the obtuse angles are exactly the same size. If you can just visually spot the sharp corners and the wide corners, you already have a huge advantage.
But to actually get the marks on the exam, you need to know the 3 specific mathematical rules. Rule number 1, alternate angles. These sit on opposite sides of the transversal, tucked between the parallel lines, and they often form a sort of Z or S shape. These are always equal. Rule number 2, corresponding angles. These form an F shape and they sit in the exact same position relative to the intersection on each parallel line. These are also equal. And finally, rule number 3, co-interior, sometimes called allied angles. These form a C or U shape sitting on the same side of the transversal. Now pay close attention here. These do not equal each other. They sum to 180 degrees. That's a huge distinction.
All right, Section 3. This is absolutely critical. The secret letter trap.
Okay, so we teachers tell you to look for Z, F, and C shapes, right? Because it really helps your brain spot the visual pattern. But listen to me carefully. If you actually write Z angle on your AQA GCSE exam paper as your reason, you will score exactly 0 marks. Nothing at all. The examiner demands precise terminology. You absolutely must write out the full geometric phrase, alternate angles are equal. And hey, if you don't believe me, let's take a look at an actual examiner's report. It literally says, frequently, the vocabulary used was ambiguous or not sufficiently rigorous for geometrical reasoning. It was not uncommon to see confusion between alternate and corresponding angles. You see, the examiners are actively hunting for rigorous, precise vocabulary. Do not hand them an excuse to dock your points.
Which perfectly leads us to Section 4, common exam mistakes. Let's make sure you avoid these traps.
I want you to run through this exact checklist in your head during your next mock exam. Trap number 1, assuming co-interior or C-shape angles are equal. Remember, they are not. They add up to 180 degrees. Trap 2, forgetting to check if the lines actually have those little parallel arrows drawn on them. Guys, these rules only work if the lines are definitely parallel. Trap 3, bringing out a protractor to measure the angle. The diagrams are almost never to scale, so measuring them is a guaranteed way to get the wrong answer. And trap 4, swapping the words alternate and corresponding in your written explanations.
So, the most crucial takeaway here is this. The single biggest mark loser across the entire GCSE maths paper for geometry is missing reasons. If you figure out all the math in your head and just write down x equals 65, you get 0 marks for reasoning. In geometry, the number is only half the battle. Writing down the geometric reason is absolutely mandatory.
Finally, Section 5. Let's bring it all together with a strategy for maximum marks.
This right here is your optimal exam workflow, your playbook for the perfect proof. Step 1. Before you even touch your calculator, look at the diagram and identify all the parallel lines marked with arrows. Step 2. State your angle calculation super clearly. Step 3. Right next to your calculation, write the exact, rigorous geometric reason in brackets. Let's see what this looks like in a real exam scenario. Say we're asked to find angles A and B. And, this is key, give our reasons. We've got a transversal cutting 2 parallel lines marked with arrows, and they've given us one angle of 64 degrees. Okay, here is the exact phrasing you need to secure every single mark available. For angle A, it's directly across from the 64-degree angle at that intersection. So we write A equals 64 degrees, and right beside it, in brackets, vertically opposite angles are equal. Perfect. Now for angle B. Notice how it's in the exact same relative position on the bottom parallel line as the original angle is on the top line? That's our F shape. So we write B equals 64 degrees, and in brackets, corresponding angles on parallel lines are equal. Do you see how the calculation and the vocabulary are just perfectly paired?
I also want to share this fantastic insider tip from the folks at Just Maths. They say, write all over your exam paper, including angles you have found. Missing angles are to be found alphabetically. I love this. Seriously, don't try to hold the whole complex puzzle in your head. When you find an angle, scribble it directly onto the diagram. And here's the best part. If a question asks for A, B, and C, the examiner specifically designed it so you can find A first, use A to find B, and then use B to find C. It's a really subtle hint to help guide your logic. If this explainer helped clear up the confusion and gave you a solid game plan for your AQA GCSE maths revision, please do hit that like and subscribe button. It really helps us out, and it ensures you won't miss out on any of our upcoming top-tier revision study guides designed specifically to get you maximum marks. All right, before you go, I want to leave you with one last provocative thought for your next study session. You now know all the numeric angle rules, but what happens when the exam board decides to throw a curveball? What if, instead of nice simple numbers, they label the angles as complex algebra equations, like 3x plus 10 and 5x minus 30? The crazy thing is, the geometric rules remain exactly the same. You just have to build an algebraic equation to solve it. Kind of wild, right? Keep that in mind as you practice, keep mastering those precise reasons, and I'll see you in the next explainer.